Hello, everybody, and welcome. My name is Professor Jim, and this is Music Impossible. We're going to start on a journey today of helping you prepare for the AP Music Theory exam. Besides that, getting a great score and getting some advanced placement credits, getting you a head start on your college journey, all things that are super important with this course. I will say that the things that are also taught in this course are foundational for your college career and your music career. There's nothing here that's wasted. This isn't like sitting in some, Algebra 3 class of stuff you're never going to use for the rest of your life. This is absolutely going to help you for the rest of your career. We're going to start off our first lesson. We're going to go in just to the physics of sound and talk about some of the science behind that. Now, our sources for this class is going to be the Barron's AP Music Theory text, as well as the Adler orchestration book, Samuel Adler, and then we have the Aldwell Schachter voice leading and harmony book. So those are the three sources we're pulling from. These are all sources that I've used in my career. Continue to use them as reference materials when I'm teaching, preparing, or even doing some of my own writing and composing. So as we get into the physics of music, we have to start looking at how sound is created. Now, when we look at sound and how it's created, and you may have heard this before, sound waves, right? A sound wave is essentially when a sound is made, a vibration is created in the air, and those vibrations push air molecules back and forth. And those air molecules getting pushed back and forth travel through the air. The disruption of that air lands in our eardrums, and our amazing ears have the ability to take those vibrations and interpret them and translate them into sound that we can comprehend and understand. It's even more complex when we start talking about music and how that works. And when we think about music, we have stuff you've heard before, things like pitch and dynamics and timbre, articulation. All of those things are contained in how sound waves and articulation envelopes are created. Now, the pitch is, of course, the note that you hear, and we call that a frequency. And a frequency would be a wavelength, and we're going to talk about what a wavelength is in just a minute. And then the dynamics is of a particular, how loud something is of a particular note is what we would call the wave height. And then we start getting into timbre and articulation, and we're going to go into Pro Tools a little bit to kind of demonstrate that as well. But here we see a sound wave, and when we have a sound wave, what we have to recognize is how often does this sound wave happen? And so the first thing we need to think about is time. And time, as we go left to right across the screen, that is time going by. And wavelengths are measured in how many times they appear per second. The amplitude is how loud something is. So we see that middle line, and that's sort of the at-rest line. So if there were no sound, you would sort of have just maybe some room tones that would have these slight small bumps across that timeline. As we get further away from that area of rest, that point of rest, we get amplitude. How tall these waves are is dependent on how loud the sound is. So we talk about dynamics when we talk about the wave height. And the wavelength is the distance between two waves. So at the top of every wave, we have the peak. So if I come over here, I'm going to use my pointer here. So if I'm looking at the peak right here, that's the top of every wavelength. And then this down here, the bottom of this wave is called the trough. And as it goes up and down, it's creating sound. And the closer together these wavelengths are, the higher the pitch. Another way to say that is how many waves appear per second. And you may have heard of something called a hertz. Hertz, abbreviated HZ, capital HZ is a hertz. And that is how many waves that we see here on the screen appear per second. And so if you've ever been sitting in orchestra class and they say, hey, we're going to tune to A440. That's that A above middle C. It's A4 on the keyboard. That means that there are 440 of these wavelengths per second. If I were to play A1, a really low A, you may only hear like in the string bass section or the tuba section or the timpani. That wavelength is going to be, A1 is about 55 hertz, so 55 wavelengths per second. So the lower the pitch, the further apart these wavelengths are. And I'm going to put in the assignment section of this lesson some other resources. If you really want to dive into this and get into it deep, the Khan Academy has some really great videos on this. And I'm going to go ahead and post a link to one of those videos if you really want to dive more into that. There's formulas and actual physics that go into this in a much deeper sense. But I'm going to do just a couple little demonstrations here. We're going to go ahead and use Pro Tools. And if you don't know Pro Tools is a production and mixing platform. It is probably the quintessential program that is used on most films and television when you're mixing sound and music. It's used in all of the big music studios and recording studios around the world. Pro Tools is the place to go. And there are some production classes in Music Impossible that are either completed or under production at the time of this recording. So let's take a look at this. We're going to go ahead and look at the trumpet. We're going to create some sound waves with this trumpet part, in both a MIDI sense and a wavelength sense, or an audio sense. So when you create a sound inside of a computer like this, and we've chosen the trumpet sound to demonstrate this, is the MIDI is computer data and information that gets interpreted by the computer and plays back a sound that matches that particular instrument. The recording of that is the audio version of the same thing. So we're going to kind of look at both of these for a second. Let's go ahead and hit the record button. I'm going to make sure I want to have my metronome playing here, my click. Here we go. All right, so a little bit of Twinkle Twinkle Little Star there. And if I were to come back here and look at these two, we're going to have the MIDI part here. I'm going to make this really big. And we see that we have different durations in music. And now we hear music in two different ways on a very basic level. We hear the pitch of the music, which equates to wavelength, and then the duration of the note as well. Of course, we're going to get into rhythms down the road in this course, but you can really clearly see here the durations as it exists here. I'm going to go ahead and change the grid. So it's going to show us quarter notes. And we can do this fancy thing called quantizing here. And we're going to make sure all those notes actually appear on the grid the right way. Okay, so if I open up this trumpet line right here, you're going to get to see, let's change the grid here also to quarter notes. You can see C4, C4, G4, G4, A4, A4. And they all have durations. These are all quarter notes. So when we think of duration, we think of how long a note appears. And if we close this down and we go to the wavelength of the exact same thing, we start to get a sense of what these wavelengths look like. So I'm going to zoom way in here, and you can see kind of these first two notes as they appear in a wave form. You could sort of see an articulation where the note starts, the rise of the note to here, and then the decay of that note. And we call that the articulation or the envelope of a particular note. Now, one of my favorite things here about Pro Tools is you can go in here and you can change the envelope of any instrument that you have. It's pretty cool. So we're going to go in and look at the envelope of this particular trumpet sound. So if I go into the trumpet window, it's going to show us a bunch of information about this trumpet sound, some volume things here and microphone positions, but I want to focus on this section right here. This is the envelope section, and I can change all of these different elements, the attack, how the sound begins. A lot of times we want trumpet to have that very sort of harsh, John Williams Star Wars sort of sound, that big giant announcing of kings and queens sound, that sort of herald trumpet sound. And so the attack is really important. Sometimes we want to have a very slow string sound where this sound kind of starts a little bit slower with almost like a fade in, when we want something a little bit more dramatic or slower. So the attack matters. I can come in here, I can change the attack right here by moving this particular dial. So right now I've got my trumpet where the attack happens right away. If I move this attack this way, you can sort of hear it as sort of like starts a little bit slower and then pipes in. It's a little bit slower. It can be very dramatic with it. It's like a 10-second fade built in with just the attack. And then I can change things like hold, delay, sustain, release. I can have the note release a very, very long way. So if like I wanted my release to last a long time, we could do that. Here's the... Only takes a millisecond to release. Almost like chopping the note off. And this is what the envelope looks like. And when you're inside of Pro Tools or in most music production software, you can do the same thing. A lot of these higher ends, especially samples, have the ability to change the envelope, the attack, hold, decay, sustain, and release of every single note. All right, the last thing we're going to look at today is we're going to go back to that wave height, wavelength thing. Let's go ahead and delete out of the little twinkle twinkle little star thing, and I'm just going to simply play an A440. So we're just going to record here. We're going to play just an A. It's the A right above middle C. All right, just a whole note there. We'll go ahead and quantize that so it's exactly a whole note. There it is. I'm going to make everything a little bit smaller here. And so there's the whole note represented in MIDI, and then there's the whole note represented as an audio file. And I'm going to zoom way in on this. I'm going to change the grid also so it's going to show us 1 second. There it is. So it's set to 1 second. So from right here to right here, this is A440, which means there are 440 wavelengths in that 1 second. So this is me zooming way in to this wavelength. Get to it. That's about a second of time that I have highlighted there. And so this 1 second of time, if you were to count them all, it would be 440 different waves. Now, samples like this are created by actual musicians on a soundstage where the recording engineers record the actual articulations and sounds from a real trumpet. So that's why it's not a perfect wavelength like we might see in a machine or just a basic tone, like a white noise tone. So there's some inconsistencies in the wave because it is an actual sound played by a human, not generated by a computer. But let's go down. Let's take this other recording. Let's go ahead and turn these off. What we're going to do is I'm going to do the same thing. We're just going to record in A, except this time we're going to record A1 in the stand-up bass. So let's bring the stand-up bass up here. And we're going to record with this one right here. Let's see what that sounds like. There it is, way down low like that. I'm going to turn that up a little bit so you can hear it a little bit better. There we go. That's just a low A. It's an A1. Let's go ahead and record that. We're going to compare these two waveforms. And you're going to see a big difference between what looks like 440 wavelengths per second and this A1, which is 55 hertz or 55 wavelengths per second. All right, so we've recorded our bass note. We're going to go ahead and just solo out just the wavelengths here so we can see what these look like right next to each other. You can already see, without any sort of big-time zoom in, the difference between these wavelengths. The trumpet one is here. They're very, very close together. Looks like we're looking at about 3 seconds of music here. And down here is the bass recording, which you can clearly see is much further apart. You can actually start to see in 3-second intervals this 55 per second. Here it is kind of in a 1 second chunk. Let's go ahead and highlight a 1 second chunk. There's a 1 second chunk right there. And if you were to count all these, it would be about 55 vibrations in that 1 second interval. So the higher the pitch, the closer together those wavelengths are. They're way more wavelengths per second. Same thing when we go down to A1. They're going to get further apart. They're going to get further apart. And depending on the timbre of that instrument, the articulation, how it's being played, those wavelengths aren't going to be perfect like we might see in our prior part of our lesson. But they are, in a sense, going to still follow the same rules. A1, about 55 hertz. A440, when I played on a trumpet, about 440 per second. Now, we don't always play perfectly in tune, right? So we have times where we are out of tune, which means if I play a flat version of an A440, well, it's not going to be 440 wavelengths per second. Now you're going to start to get a little bit of a lower pitch, so you might get 420 or 410. And that pitch is going to start going down, and you're going to be out of tune. And so when we try to match pitch, and you know how if you're tuning instruments, and they sort of, you can hear this wah 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 wah, and as soon as they're in tune, you get less of that sort of wah wah sound, those vibrations, those competing sounds in your eardrums when we're out of tune. All right, so that's our first lesson for the day. Here's my big tip for this entire class: do the work. Print out all the sheets, watch all the extra videos, do all of the assignments, do all of the quiz, everything. Some of it's going to be repetitive. Some of it's going to seem like, oh, I already know this, I don't have to do it. Do the work, even if it's super easy. Even if it's easy for you, you're building great foundations. And that repetition, it's a lot like math music theory is. The more you do it, the better you're going to be as we continue to build on this initial foundation. All right, everybody, thanks for joining me. We'll see you in lesson number 2 real soon.